Welcome to the DIY Honda Garage channel. The DTC P0191 indicates a malfunction involving the fuel rail pressure sensor, which measures the pressure within the fuel rail. The sensor's readings are essential for the engine's fuel management system, as they help determine the optimal amount of fuel injected into the engine. This specific code points to situations where the sensor's output voltage falls outside of specified ranges, either below 0.27 volts or above 4.89 volts, leading to potential engine performance issues. The fuel rail pressure sensor is located on the fuel rail itself, which is usually situated near the engine intake manifold. Maintaining proper pressure is crucial for efficient engine operation and to avoid further complications. Addressing this error promptly can help prevent more significant engine issues down the line. The error description for DTC P0191 refers specifically to the fuel rail pressure sensor, which is integral in monitoring the pressure of fuel within the fuel rail. This sensor's readings directly influence fuel injector operation, as too little or too much pressure can disrupt the optimal fuel-to-air mixture needed through combustion. In the Honda Fit, the sensor is typically mounted on or near the fuel rail, which is easily accessible for maintenance and troubleshooting. The sensor provides real-time feedback to the Powertrain Control Module, PCM, regarding current fuel conditions, which allows the PCM to adjust fuel delivery accordingly. If the sensor's output voltage is out of the normal operating ranges, it signals potential issues that must be addressed to maintain engine performance. There are several possible causes for the P0191 error code that should be investigated. Firstly, a faulty fuel rail pressure sensor is a common culprit, as it may provide inaccurate voltage readings, leading the PCM to misjudge fuel delivery needs. Another possible cause could be poor electrical connections or loose terminals at the sensor or PCM, which could disrupt the signal transmission and result in out-of-range voltages. Lastly, a malfunctioning PCM, which is responsible for interpreting sensor data and controlling engine functions, could also display this error if it miscalculates the connections or signals it receives. It's imperative to thoroughly investigate each of these criteria during the troubleshooting process. Drivers experiencing the P0191 DTC are likely to observe several symptoms associated with fuel system issues. The most immediate indication is the illumination of the check engine light, CEL, on the dashboard, which is a warning that the engine control system has detected a fault. As a result of the sensor malfunction, you may also notice poor engine performance, which could manifest as hesitation, rough idling, or stalling during acceleration. These performance issues occur because the engine is not receiving the correct amount of fuel due to improper pressure readings. Additionally, reduced fuel efficiency is another symptom, as the engine may overcompensate by injecting more fuel in response to perceived low pressure, leading to unnecessary fuel consumption. These symptoms should prompt immediate attention to prevent further engine damage. The first step in troubleshooting DTC P0191 is to turn the vehicle to the on mode to activate the electrical systems without starting the engine. Once the vehicle is in this state, use the HDS Honda Diagnostic System tool to check the fuel rail pressure sensor's input voltage. This is crucial because the HDS will read the actual voltage signal output from the sensor. According to the specified thresholds, if this input voltage is less than 0.27 volts, it confirms that a failure in the voltage signal is occurring. If the condition matches this threshold, that indicates that the failure has been duplicated, allowing the technician to move to the next troubleshooting step. If the threshold is not met, further investigation is needed to troubleshoot additional parameters. The second troubleshooting step also requires the vehicle to be in the on mode. Here, The same parameter is assessed again, looking specifically for instances where the input voltage from the fuel rail pressure sensor exceeds 4.89 volts. If the conditions reveal higher voltage, it again indicates a failure that has been duplicated, which prompts the technician to advance to step 7. Conversely, if this threshold is not met, this may suggest that the failure is intermittent or that the system is operating momentarily correctly. At this stage, technicians should examine for poor electrical connections or loose terminals at both the fuel rail pressure sensor and the powertrain control module, PCM, as these could lead to erratic sensor behavior. It may also be beneficial to replicate the fault conditions as documented in the onboard snapshot of the DTC, as this can provide additional context for troubleshooting. In the third step of troubleshooting, the vehicle must again be turned to the off or lock position. Next, the technician disconnects the fuel rail pressure sensor 3P connector to isolate the sensor from the system. With the connector detached, it's important to return the vehicle to the on mode so that the fuel system can be energized. The technician should once more use the HDS tool to check the input voltage. If the voltage is less than 0.27 volts during this state, the technician can confirm that a fault has been detected, leading them to proceed to step 6. However, if the voltage does not match this threshold, then further investigations must continue, as it indicates that the voltage supply might be affecting system performance elsewhere. Step 4 in the troubleshooting guide involves a direct voltage measurement between specific test points while keeping the fuel rail pressure sensor 3P connector disconnected. The technician will measure the voltage between test point 1 and test point 2, specifically looking for an approximate value of 5.0 volts. This measurement is critical because a reading near this expected value indicates that the voltage operating range is being maintained correctly. If the measured voltage checks out at approximately 5.0 volts, this suggests that the issue is likely with the fuel rail pressure sensor itself, leading to a recommendation for replacement. On the contrary, if this voltage is absent or significantly less than expected, this indicates further problems that must be assessed, necessitating progression to the next troubleshooting step. At step 5, the vehicle is taken back to the off or lock position. Then, similar to preceding steps, the technician uses the HDS tool to short the SCS line and waits for over 1 minute to allow the system to reset. After this, the technician disconnects the PCM connector C, specifically the 51P terminal. With the relevant connectors disconnected, the next task is to check continuity between 2 specified test points. One at the fuel rail pressure sensor 3P connector and another at the PCM connector. If continuity is confirmed between these 2 points, it indicates that the VCC1 wire is intact and that the failure still exists within the system. In the case where continuity is not found, this indicates a fault characterized by an open wire along the VCC1 line, and repair at this point becomes necessary. The 6th troubleshooting step requires the vehicle to again be placed in the off or lock position. As before, temporarily short the SCS line with the HDS tool and allow time for the reset. After restoring the system, the technician should disconnect the PCM connector C, specifically the 51P terminal. With those connections severed, checking for continuity is again necessary, but this time between the fuel rail pressure sensor 3P connector and the body ground. If continuity exists, this indicates a potential short within the PF wire itself, which should be repaired. If no continuity is found, it indicates the PF wire is in good condition, suggesting that any further issues might arise elsewhere, possibly indicating a malfunction with the PCM. In the 7th step, begin again by bringing the vehicle to the off or lock mode. the technician will disconnect the fuel rail pressure sensor 3P connector and use a jumper wire to connect terminals A and B within that connector. This step simulates normal voltage signals that the PCM expects from the sensor. After establishing this connection, turn the vehicle back to on mode, allowing the technician to assess the voltage again using the HDS. If the input voltage here exceeds 4.89 volts, it means the conditions signal that problems likely reside within the sensor itself. Conversely, if the threshold is not met, a replacement of the entire fuel rail, including the fuel rail pressure sensor, may be necessary, as it indicates failure in parts of this assembly. Step 8 involves removing the previously connected jumper from the fuel rail pressure sensor and turning the vehicle back to the on state. The technician is then required to measure voltage again between specific test points, one being the number 2 terminal in the sensor connector and the other being the number 3 terminal. Here, the technician is looking for a voltage measurement of around 5.0 volts. Achieving this reading indicates that wiring for the fuel rail pressure sensor is operational, and the issue of why the sensor might be outputting faulty signals warrants further review. If the voltage fails to meet expectations, this requires further exploration in the next troubleshooting step, which will identify open circuit or wiring issues. The 9th step entails taking the vehicle back to the off or lock mode. The technician should again initiate the SCS line short with the HDS for proper system reset before disconnecting PCM connector C, particularly at the 51P terminal. Now, the focus is on ensuring continuity between the second female terminal of the fuel rail pressure sensor connector and the appropriate pin at the PCM. If continuity is present, it signifies that the SG1 line is intact. In this scenario, we would then review any technical service information related to associated DTCs for further understanding of symptoms. If continuity is absent, this points towards an open wire issue within the SG1 line itself. Such faults necessitate detailed repairs to restore proper connection and function of the sensor. In the final step of troubleshooting, DTC P0191, revert the vehicle to the off or lock position. Again, a short should be created with the HDS to initiate a system reset, followed by disconnecting PCM connector C, specifically the 51P terminal, for continuity checks. The technician now measures between the first terminal at the fuel rail pressure sensor 3P connector and a specific point on the PCM connector. Confirming continuity would imply that the PF line is functional and that other avenues of fault need evaluation. If no continuity exists, a repair would be warranted to fix an open condition in the PF wire between the two connections, which may ultimately resolve the DTC being logged. After completing the necessary repairs for DTC P0191, it's critical to undertake final verification steps to ensure that the error has been successfully addressed. Begin by using the diagnostic tool to scan for any remaining trouble codes. If P0191 or any related DTCs are still present, additional investigation may be required. If the system appears clear of errors, proceed to clear the DTCs to reset the system's diagnostic status. This step ensures that the PCM's fault memory is refreshed and allows the system to start fresh. Lastly, a thorough road test is advisable to confirm that the vehicle operates smoothly under various conditions, ensuring that the adjustments or replacements made successfully eliminated the initial symptoms and reprogrammed the system appropriately. To mitigate future occurrences of DTC P0191, incorporating preventive maintenance measures can be highly effective. Regular checks of the vehicle's electrical system will help ensure that all connections remain clean and secure, especially at critical points like the fuel rail pressure sensor and PCM. An inspection of fuel system components should also be part of routine maintenance. Replacing aging or worn components before they lead to issues can help maintain the system's functionality. Additionally, using quality replacement parts whenever repairs are needed will contribute to the reliability and longevity of the fuel system. By adhering to these maintenance strategies, vehicle performance can be enhanced and the likelihood of DTCs related to the fuel rail pressure system can be significantly reduced. In conclusion, understanding the implications of DTC P0191 is vital for maintaining the Honda Fit's performance. The troubleshooting steps outlined provide a comprehensive approach for diagnosing and addressing issues with the fuel rail pressure sensor and its associated circuits. Following each step meticulously will ensure that technicians effectively pinpoint the source of the problem and implement the necessary solutions. Equally important is the role of regular maintenance checks, which can help prevent such issues from arising in the first place. Ultimately, proactive care and timely intervention will lead to smoother vehicle operation and improved reliability over time. Please like and subscribe to the channel. See